Hello, everyone. Thank you for joining us. I'm Guillermo Varela from McNeel Europe, and I'm going to introduce today's speaker, Gijs de Zwart. He is a design professional focused on high-quality design visualization, and he has recently joined the McNeel team, but he has been a Rhino and Grasshopper user for many years. Also, he is a freelance designer, Rhino trainer, and has developed some plugins like Global Edge Continuity. Today, he's going to show us how to rebuild some 70s soft electronics products in Rhino from scan objects, and also how to render them and prepare a product presentation. Please remember that you can ask questions in the chat and we can answer them in the last 15 minutes of the webinar. Also, the webinar is being recorded and we will upload it to YouTube tomorrow. Thank you again, and please, Gijs, start with the presentation if you're ready. Thank you.
Thank you, Guillermo, for the introduction.
You're welcome.
Yeah, let's start with giving a brief intro about myself, and then I want to quickly go to the actual part of this webinar, the surface modeling part. So I've been working with Rhino since 1999. That's also the time when I graduated from Delft University of Technology, the industrial design engineering. And for me, Rhino was like the program that allowed me for the first time to actually draw something that I had in my mind. So the free-form surfacing of Rhino was not known at that time to be accessible to mainstream computers. So it was kind of love at first sight for me. So I started in 1999 as product designer at TriStar Europe in Tilburg. And I worked there for about 7 years until I thought, well, I want to do a little bit more freelance work as well, because that started happening with Philips design trainings, and I wanted to make the step towards being a freelance designer, and that eventually happened in 2008. So from then on until still now, I'm a freelance designer, and recently also joined McNeel as product designer and focusing on product support and training material. So let's jump right into the actual modeling part of this webinar. So what I want to focus on is modeling this 3D scan. The scan was provided by a generous user on the McNeel forum, and that was the link actually I wanted to show on the other computer, but unfortunately that didn't work out well. So
I can share it, don't worry.
Yeah, maybe you can
Yeah.
share that name of the user that shared this 3D scan. It's a marvelous scan, I think, and so it's a good source for starting a remodeling of this surface model. So what we have here is a mesh model, and we go to shaded mode. Then you'll see that I'm making this a certain color, but also a certain transparency, and that allows me to see through the object while I'm surface modeling. So eventually what I want to show is the actual surface model when it is finished. So that is this part of it. So we'll do a step-by-step through this surfacing. And I will be also using the plugin XNURBS for that. And a little bit later, I will show why. So first of all, if you start with a surface model on a mesh, then for me, the easiest is to find certain sections that are the most significant in that model. So for example, a section of the handle, a section of the spout, and the section in this case of this part of the housing. To draw these sections, I normally start making freeform curves that have the least amount of control points necessary for that shape. So if I make a clipping plane, let's do that in this layer. And move that down to the handle section. And now I'm moving my C-plane to 0, this way. And then set my C-plane to that object. So C-plane to object, I have a shortcut for that, CO. And then I would typically start a section in that C-plane. So in this case, let's see if we can make a degree 5 curve. Like that. Let's lock my mesh here so that I don't accidentally move it. So once I created the framework of this curve, I can start editing it. And then moving control points until I'm satisfied. I noticed that my screen is a little bit slow here with this recording on, so please bear with me if it feels a little bit slow here. So something like that. And you see that I'm getting quite a good result already. Eventually, what I want to do is have a curve that has a tangency towards the eventual mirror plane. And the reason for that is because if you're starting to mirror eventually the shape, you want the first control points of this curve to be perpendicular to the, in this case, the YZ plane. So looking at this model here, that's this plane here in the right. Let's give a little bit of background about that part. So if I'm creating a curve like this, then these two control points determine the tangent direction of this point here, and these two determine the tangent direction in that point over there. So that means if this one is not aligned with this point, you will not get eventual tangency towards the rest of the shape. I hope that makes sense. So let's go ahead with this curve here. So I'm creating sections, and this section will probably end up somewhere there. And this one I can simply extrude up to create the base surface of my handle. Let's do that in surfaces. Switching back to my world C plane, I also have a shortcut for that one. And then in my right view, turn on control points here. This is actually a extruded object and an extrusion. That's why you get this kind of view. That means I can modify my extrusion this way. So I'm moving this slightly out, just a little bit. And that should already be quite fine for this first part of the handle. So exploding gives me back the actual surface points. I can still see if I need a little bit of fine tuning there. And so maybe move these points over a bit. Like that. Then the spout section has to be drawn, which is kind of a circle. And this part is also starting from a circle, but then you see that this section is a little bit smaller than that section. So I created some base curve for that. I will not do that part here in this webinar because I think it kind of makes sense how that is done. These are all circles. And again, these two circles are identical for the same reason as the curve has the first two control points in line. And I will show you right now why that is. So if I turn on control point, you see that these are just circular shapes, circles. And if I loft those, and I choose a loose loft, I don't see my own. Oh, there it is. So loose loft. Then that will mean once I mirror this surface over the y-axis, because the control points in this direction, these two are aligned. That means that this surface and that surface will be not only tangent, but curvature continuous. We can clearly show that with zebra stripes. So these are now aligned and form a perfectly smooth transition. So let's delete that one. For the spout, I'm just creating an extrusion. And that forms the basic surfaces of this design. And then starts the more intricate part of the surfacing, because we need to make some transitions. And these transitions can be made in various ways. I'm going to start with this part of the transition and make a filleted surfaces. I have a G2 blend fillet surface for that. And I set the trim and extend to no both. See, this is already quite okay. We will readdress this. This is just a kind of a preview of the transition that we are going to build, and not the total actual result of it. But we can already see that this kind of works. We can do a blend, sorry, a zebra with suppose if we are looking at this model here, and we see that this part here is not actual part of this surface. So the transition needs to somewhere stop here, and then we need to find a different kind of surface for the rest of the transition. In order to do so, I will make a blend curve that kind of goes from this point to that point. Let's do that. Blend curve. Actually, I need to split this part with a cut plane over the y-axis. Then I can make my blend curve. You see that Rhino will make kind of a blend to the end of this line here. So I need to flip that one. Move this over. Best is that to do that in right view. I notice my screen is really, really slow here, so it's kind of difficult to make this happen here. I'll just show you the process of it, and then I will turn to the curves that I already created. So what I'm typically doing is finding the way to make the transition as fluent as possible. Let's see if it's my mesh here. And this is already off, so let's do that. The curve is not quite good here, but I will switch to the already created curves because that is probably better to show. Let's see. Okay. Let's go a few steps back here. So I've created that curve to transition between these two edges. And now I'm going to make a trim curve, that's this one, to trim off this part. You can kind of see that. Oh, I think I've deleted my mesh. Is that so? No. There it is. You can kind of see that here if you just show this layer in rendered view. That is best to see. That's how this this surface kind of has a trimming line there. And here it is a little bit more difficult to see. But there you also kind of see that the surface ends there and gets a transition over there. So let's go back and shade it. So I'm creating two trim curves. This one I trim this part off. And for this one, I'm using that trim curve. And this surface I have already trimmed, but let's undo that first. And make a trim curve over there. Now this trim curve here, since I'm going to make a transition surface here, if I would trim this surface like this, just something over there in the middle, like that. You will see that if I make a transition between these two, for example, with a blend surface, that this surface tends to dip down a bit. And the reason is because this curvature, if you want to extend the surface, it wants to extend in that direction. Let's annotate that a little bit. So it wants to go down, and this one wants to go in that direction. And that will end up in that kind of dip. So what we need to do is make it a little bit easier on the transition surface. To do that, we want to create this particular curve. Let's hide that for now. Make a new blend curve. Here you can see that if you move this along this edge, until this point here is kind of aligned with these. And then you get a more fluent transition to that particular surface. Okay, so that's the kind of curve I want to build. And then if I split the surface on that end there, and I make a new blend surface here, you see that this transition is now much more fluent and doesn't have that dip anymore. So that's the principle of creating these reference curves for the eventual surfaces that I'm going to build. So again, I'm going to borrow some of the surfaces that I already pre-created. That's this one. I'm going to split this edge here at that point. And then I will build this transition surface. I will use XNURBS for that. So with XNURBS, you can define surfaces based on less than 4 edges, and you have a lot of control over how that transition is going to work. You can kind of see that. So technically, this is also possible with a blend surface. But as you can see with blend surfaces, it always goes kind of perpendicular to the surface edge. And I would have to move these points there to align them. And in this case, it gives a little bit more dense surfaces. And this could also work. We will see in the next step. So the next surface I'm building is actually this whole filled surface there. For that, I'm making 2 helping surfaces. And I'm splitting this edge here. Well, that has already split. And then I should have all my boundaries in place. And all I need to do is make another curve there. This can be done with an arc blend. Because these are the same radius, the arc blend will be the same radius as well. And let's start another XNURBS surface. So here I need curvature continuity, same as here. And you'll see that in the process of creating the surface, you can already see the preview of it. But it is a little bit slow at Zebra, so I'll turn that off. This one needs just positional continuity. This one needs also curvature continuity. And for these edges, I just need tangency control. Because eventually, if this has a certain curvature towards that surface, which is tangent, then eventually, if you mirror the surface, it will mean that the curvatures are the same for these 2 surfaces, and they're tangent, so making them practically just curvature continuous. So for now, let's hide our curves. Hide the helping surfaces. And yeah, you can see that this is already quite good in terms of surface flow. So eventually we get this total surface, which we can still manipulate a bit. Now that's something that's also quite interesting about XNURBS. If you make that with history recording on, you can always edit a surface. In this case, it has lost its history. So let's redo that surface. Again, curvature on these edges. I need to redo my arc blend here. So XNURBS, curvature on these. Position on this one. Tangent on these edges. And once that is done, you can still modify the surface with the XNURBS edit tool. Now, if we turn on zebra stripes for everything here, and I want to manipulate the surface, I can do that even with just a point object. And so if I edit this XNURBS and choose this point to be a non-boundary constraint, once that point is added, I can still manipulate the surface. As you can see, if I just move that control point around, it will modify and update the history of this particular surface. So this way you can do really fine-tuning, making a little bit of rough movements here to illustrate how it is working. So let's go back here. Once all these steps are in place, and we mirror that over to the other side and create our joint surface model. And let's have another look at the zebras here. Here you can see that because of the tangency set on these helping surfaces, the eventual surface will be curvature continuous. So I hope that makes sense a bit. Now, another thing I want to show is how you can turn this model eventually also into a quad surface, a quad subdivision surface. For this, I use the QuadRemesh tool. Actually, let's make a new QuadRemesh layer. And start QuadRemesh. So by default, it creates like 2000 quads, which in this case is way too much. I'm using Y symmetry, so it is symmetric along the YZ plane. And 250 seems to be quite a good number. Okay, so this model is already quite okay. Once that is done, let's turn on back the mesh here and hide the surfaces. So this one, move that to this layer. Because it makes a subdivision surface based on the control points that lie on the actual surface. The resulting subdivision is quite a bit smaller, as you can see. For this, I will just offset it with offset sub D. Point H seemed to be quite okay. And after that is done, I can start manipulating this subdivision surface. Now, one thing that you notice is that QuadRemesh made an all quad surface, which is good, but then has these kind of weird shapes in there that need to be removed. Now, for that, I prefer to weld these 2 points. And a quick shortcut for that is something I made aliases for. So I have the alias Z for stitch, and that says pause, a second enter. And that basically forms the macro for welding this point to that point. Or if you weld 2 points at the same time, it will just choose the middle point. I'll demonstrate that here. If I do a Z for first to second, it joins like that. If I Control Shift select these 2 for subselection and Z, then it makes the middle point. I think in this case, both can be valid, but probably this one is a little bit better. So the middle ground. So let's do that. And I'll do the same there. And then I can make a symmetric model here with the reflect command of the y-axis. And this already gives a quite decent mesh here. A little bit of an issue there. Let's see if we can address that. These extraordinary points will always be a bit of an issue in subdivision surfaces. And I will show you in a bit also how that looks once you convert it back into a normal NURB surface. So that will always be a little bit of a problem. Now these are now not very circular, and a while back I made a script for that to circularize those points. And that turns all those points into an equal spacing. And we can do the same for the front. And there is a little bit of a caveat here because if you do that on a symmetric model, then it won't work quite well. See that it kind of removes that point there. So I need to remove the symmetry, then turn on the control points and circularize those. It will kind of rotate these points sometimes. It depends a bit on the model. But you can quite easily fix that by rotating from the center of the circle to this point and then moving it up again. And then I would typically align all those points here to be aligned with those front points. Because if you look now on the front, they're not quite aligned. Now to align those and make sure that you don't mess up the rest of the control points, I would typically select those. Say I want to keep those in position. Then I hide those with hide PT. And then I use set point on these points. Set point in X and Z in this case. Align it to that point. And work my ray around it. So eventually that leads to this QuadRemesh. Where this is perfectly circular. Well, as much as possible, of course, because eventually a subdivision surface is never perfectly a circle or an analytical surface. So let's talk a little bit about once you convert this back into a NURB surface. This can be done with two NURBs. So this is the default. And you will see that at those extraordinary points, you will get 5 surfaces that meet at one point, and that is difficult to solve. So what you will see if you zebra this, see if I'm in parallel mode here. Yes, I am. So if we really zoom into that point, you will always get a little bit of a kink there. So no matter how dense you make your mesh, you will always get a little bit of those issues in a sub-D. Now there is a little bit of a trick to kind of solve that. So if you would trim this with a couple of spheres, something like that. Okay, and split it with the spheres. Lead those. Then we can make kind of a NURBS patch again with X NURBS. Curvature continues. And although that might work, it is kind of ugly, I think, and I wouldn't like to send this to a client for that matter. But I just want to show, oh, this is not possible. Need to do it one at the same time. I want to show that it is kind of a solution to fix that. And you get rid of those nasty dips this way. Okay, so that kind of concludes the surface modeling part. Maybe it's good to do a round of questions before going to the next part of the webinar.
Yes, we don't have any questions yet, but if anyone can want to ask something, you can use the chat. But if not, you can continue, and if we have any questions, I can ask you.
Okay, let's see.
Yeah, we have one now.
Okay, why do you go from NURBS to sub-D and back to NURBS? What benefit does the sub-D phase give? Well, what I would say is that if you're in a more like concept phase and you're roughening out a surface, and then turn it into a quad mesh, and now this quad mesh is a single surface that can very easily be manipulated rather than with a NURB surface. So I can imagine that in a very early stage of development where you're still working on the actual shape and making sure that everything in your product fits, then this can be really powerful to make edits to. So if I now want to make an adjustment to this transition, for example, if I would need to do that in the normal NURBS model, that would be kind of starting all over. Whereas in this model, I can still do modifications easily, even with this kind of previews. And then if you would create a subdivision model that is kind of sufficient for the kind of production that you're doing, for example, vacuum forming, or I think in normal injection molding, it is also certainly possible to use these models. Then there is certainly a possibility to avoid the rebuilding in NURBS and save some time this way. I hope that answers Suki Thomas's question. And otherwise, let me know. Okay. All right, so let's go to the next part. Is looking a bit at visualization. And for that, I want to look at this particular model. So this, some of you probably have seen this already on the McNeel forum. And I want to give you a brief overview of how I approach visualization of a product like this. And for this, I'm using V-Ray as a render engine, but it will kind of apply to every other render engine as well. First of all, if you're creating a render, then it is very important to make a composition of the product that you actually want to show. So, what is a nice angle to display this product? What is the angle that gives the most information about the product that you're trying to share with either your clients or your customers? That is kind of the first question. So, for example, if I'm moving around this product, and then I would say, okay, this is certainly not the right angle, and because it kind of hides the shape of it. Let's put it rendered. And for me, this kind of view gives me a good idea of what the shape of the product is. You can still see this detail. It gives an interesting angle. So if you look at the angles of the image, this cross here, it kind of fills that whole space as these two dynamic lines. So that is kind of the thing that I'm looking for in an image, if it generates a nice looking image. The second important part is that eventually, if you're visualizing, then all these small details are going to be important. So these small radii will be important. It is not always necessary to model them, though. In Rhino, you have the option to do edge smoothing, edge softening, it is called. And this will do a display modification of the display mesh. Hope this works here. It is a little bit slow, I think, on this model. It's good, I think. Normally, I don't use that edge softening because it's, in many cases, quite slow on models. I don't know why it hangs that particular model, but what I typically use is the built-in edge softener of V-Ray. Let's have a look at that. So if I have this particular object here, and I would render it out. Let's make it a bit smaller here. You see those small radii which are normally formed when you do a plastic product injection molding. And those little details are important when you visualize. But you don't need to model those in general. To do that, you can modify the material itself. So let's go to this material. And V-Ray uses a special kind of bump map for that. It's called a local space bump map, where you apply a so-called edges bump. It's a bit weird that this is a bump map, but that's the way it works. And this is the radius in real units. So that's really helpful. Avoids you to fill in all those small details if you need to. And especially parting lines that are typically relatively sharp, but you don't want to fillet those just for the visualization. So once you have that set up, you need to start looking at the lighting. And what I normally do is to make sure that I start with a completely black scene. And the reason for that is that I want to make sure that all my lighting is controlled and that there is no accidental environment lighting being used in the scene. Now for this setup, I've created a backdrop. And created 3 lights. So that's in general my setup. I have 2 lights coming from either side and a fill light from the top. And those lights in V-Ray, you can let's open my V-Ray asset editor. Lights in V-Ray you can apply a mapping to or an image to make them a little bit less harsh. So normally they're just perfectly square. See if I can enlarge this a bit. And with this texture, which is a procedural texture gradient, so I have a gradient in the U direction and one in the V direction. And then I apply that into a mix operator to make this squarish mapping. So it's quite powerful. So apply those to all the rectangular lights. And that typically gives much smoother edge on your reflections. Okay, looking at my lights here. So this light and this particular light have a setting of 20 intensity, and then the fill light is a bit less. And in V-Ray, you can also add a so-called light mix modifier. And that is also quite powerful because that allows you to study the lighting of each and every individual light. So a good habit before you start rendering the actual materials is to make a material override. Let's see where that is located there. Let's make that a default gray. Something like 75%. And then once that is activated and I render out my scene, I select it actually. And you can get a good feel of the overall lighting of the object without being influenced by the materials. So as I said, I typically start with a black scene. And then I study each individual light. So this is the contribution of each individual light. And the left one and the top fill one. Another technique for that is to apply false colors. Especially if you have a lot of lights in your scene, that is really helpful. So that you can clearly see where the contribution of the light starts and where it ends. There's one note about this light mix. Although it's really powerful, it also slows down the rendering. So if you kind of set up with your lighting, then it is faster to turn it off. So let's remove the override here. And delete the light mix. Remove my material override. Make another test render. So if I'm lighting an object like this, then what I'm looking at is light reflections that emphasize the shape. So here you see that this long light in my scene, these two, they throw a nice long reflection on the handle. And a more subtle light on top helps to define that rounder shape here. Okay, let's see what else. So I'm using a progressive render here. That's and I'm using CPU render because my machine has a powerful CPU setup. Nowadays, most people use either CUDA or RTX rendering. But on this machine, CPU rendering is still a lot faster. And for that, I also use a denoiser Intel OpenImage that works the best on this machine, but your own machine may be different in that. So maybe your system is faster using the NVIDIA artificial intelligence denoiser. But in general, the denoiser is really fast, as you can see, because if you're rendering out and you see that this noise now starts to clear, and then now already the denoiser kicks in, but you can see that it is still quite noisy. So switch it off. And so this allows you to make renderings really quickly. Also with this sharpening tool, helps a lot in defining your image. You see that without, it's maybe not so clear on screen, I don't know. But for me, it's very clear that this gives a much more punchy image. So the sharpening and denoiser are really fast in enhancing the image quality. Are there, in the meantime, any questions regarding what I've been showing? I don't see any questions yet on the chat, but so yeah, that basically concludes this part of the presentation. So I'm wondering if there are some final questions, maybe. How to make the shadow more hard? Oh, that's a good question. If you're looking for more punchy shadows, then it means you also need to make your lights more pronounced, but also smaller in area. So if, for example, we want to do that in this scene, I'll add a new light here. Point that at my object. Let's go to the V-Ray asset editor again. So I make this 50 and disable the rest. And let's re-enable the light mix. Actually leave those on. Something is off here. Let's see. It's pointing different direction. So here you can see that the shadow is quite a bit more harsh. So if you want to create even more harsher shadows, that basically means making this very small. Let's put it slightly in a different location as well. Now, the smaller the light, the more intense it needs to be to show up. And let's add a little bit of the fill light of one of the other rectangular lights. Let's see where it is, this one. So I hope that makes sense. Oh, there's one more thing I want to show actually, and that is in the original scene, you've seen that there is a ground plane that has some detail on it in the form of fur, and that looks like this. It will take some time to pre-calculate the fur hairs, so that takes a while. Once that is done, the render is quite fast. Here you see that the denoiser has a bit more hard time with this kind of patterns. You also choose to minimize the effect a bit. And the way to make this fur is relatively easy. So you have an object that needs to have a mapping. And so if we look at the actual object, then look at its, oh, this is my light object. This one. This is the fur object that has a mapping. In this case, this is the size of the mapping. And it has been applied a fur object. And I control the length of it with a map. In this case, this is the mapping for the length. That means that the lighter objects get a full length set, and the darker areas get a shorter length. So this is the max length, and this controls the actual length. So this kind of multiplied by this number. So if I make this 5, 4, and I re-render, then you will see that you get much longer furs. Will still take quite a while to pre-calculate, of course. And the reason why you don't see the pattern very clearly right now is because the fur has a little bit of bend to it. So it kind of bends into itself. So probably this is a little bit of a bad example. But I think you get a point, so this gets multiplied by the length of it. Okay, so I wonder if there are any more questions, and otherwise I would say we could conclude this session.
Thank you, Gijs. I don't know if we have more questions. You can use the chat, but thank you so much for the webinar. I think it has been great.
Thank you.
Because the strategy is really simple, but then you have a lot of tips and tricks to fix everything and to make it perfect to have great reflections and great renders.
Mm-hmm. I apologize a little bit about the things that went wrong, because I had it prepared quite well, but some things just didn't run as smoothly as I had hoped with this recording. But I hope it was still useful.
Yeah, I think so.
Okay.
It's the problems of the presentations always, but nothing else.
In terms of the surface modeling part, I will share the model that I've been preparing. So we'll post that in when you post the link to the video. Yep. We'll post it under the video. For this rendering environment that I've been showing, I'm not going to share that one because it's part of my my personal files, so to speak.
Yeah. Yes, I also shared the links to the Discourse topics, but I will share them on the recording also in YouTube.
Okay.
And yes, if you need to share anything else, I can put the links in the YouTube also, the YouTube recording.
All right.
Okay, so it looks like we don't have any questions. So thank you again.
Yeah, I want to thank everyone for attending this meeting, and hope to see you somewhere else, maybe on the forum, maybe in real life. Let's see.
Yeah, perfect. Thank you. Bye-bye.
Bye-bye.